Hello and welcome to the Coda Press video for sizing the load requirements for appliances. Okay, so there's a little bit of a catch here. It's a little confusing sometimes, but we're going to be spending all of our time for this particular question. Let's just look at the question real quick. It says, using the standard method of calculation for a one-family dwelling, determine the minimum demand in volt-amps for service conductors where the residence has the following three fixed appliances installed. You've got a water heater, a dishwasher, a garbage disposal, and a trash compactor. Okay, so the reason this is a little funny is appliances or for a house, for a dwelling unit, are sized two different ways. Okay, they either fall in that general small appliance branch circuits requirements for kitchens, that's found in 210.11 and then also referenced in 220.42. That's 210.11. I want to say C1. Is that correct? I believe it is 210.11 C1, and also referenced in 220.42. That's our 3 volt amps per square foot, right? So if your appliance is just sitting on the counter and plugged in, and you can move it to another counter and plug it into another plug, then it's covered in one of these. Okay. For these, though, these are fastened in place. These are fastened in place. So we want to look at section 220.53, where we're talking about appliances that are fastened in place. Okay. Now the other catch, it's appliances that are fastened in place. So if you think about the appliances that are fastened in place at a residence, we cannot include for this our cooking equipment, clothes dryers, space heating equipment, air conditioning equipment, or electric vehicle chargers. So the reason we can't include any of those is because, well, they have their own demand factors that are specific. So if you think, okay, well, any appliance that's fastened in place and it's not one of those 5 things, and doesn't just sit on the counter, like I said, it's fastened in place, what's left? Well, in this case, we've got a water heater, a dishwasher, a garbage disposal, and trash compactor. Not too many other appliances that are fastened in place. They're going to fall in this category other than the ones that it lists here. So these all do fit that category. So we can go ahead and literally we just add these all up, right? It says, hey, if you've got 4 or more, they're fastened in place, they're not one of those 5 types of loads, then you can apply a 75% demand factor. So all we have to do is add these all up. So we've got, 4,800 volt amps plus 1,200 volt amps plus 1,150 volt amps for the garbage disposal. Then we got the trash compactor, rounding it up, 800 volt amps. So we add these all up, plug them into our trusty calculator, and we get a grand total of 7,950 volt amps. Okay, so for our demand, we can apply 75%. We can derate that 75%, right? Apply a 75% demand factor, that is. So plug that into our trusty calculator. It gives us a grand total of 5,962.5 volt amps. And because of 220.5, I want to say it's 220.5, 1 or 2, A or B, 1 or 2. Let's just look. Of course, 220.5B. We can round, right? So round up to the nearest whole volt amp, the nearest whole number, which gives us a grand total of 5,963 volt amps, which makes our green light correct answer. In this case, our last option here, 5,963 volt amps applied to the size of our service for these fixed appliances.